All right, in this worked example, we're taking a look at electric fields, and this question comes from 2018 question paper 12 from the spring administration. It says an electron passes into the space between two parallel plates that are 5 centimeters apart and which are maintained at electric potentials of positive 2000 volts and negative 500 volts respectively. What is the electric force on the electron? In order to calculate the force, we're going to think about, we can calculate the electric field strength between these plates. A proton would be repelled by this positive plate, right? So the direction of the field is this way, just for sort of to be more thorough with this. It doesn't ask us, to consider that, but it's worthwhile review. So we first calculate the electric field strength from the information given. And what many students will incorrectly do is determine the potential difference between these plates as 2000 minus 500. If you think about the difference in the voltages like this voltage minus this voltage, then it's 2000 volts minus negative 500 volts. And so the potential difference between these plates is actually 2500 volts, not 1500. If you incorrectly substitute 1500 volts in the numerator here, you will get choice B, which is up there designed to capture those students that make that mistake. So if you're watching this video, if you happen to be in class right now and you're paying attention, so you'll learn that and you'll go, okay, I won't make that mistake. If one plate is negative and I want the difference between them, you're actually adding them, right? Because you're subtracting the negative 500 volts, right? So you're really adding the 2500 volts. Don't forget to convert your centimeters to meters, so 0.05 meters. So this gives us an electric field strength of what, 50,000? And then a volt per meter is the same thing as a Newton per Coulomb. If we then multiply this number, the electric field strength, by the charge, okay, then we're solving for the force, and that's what we want to know here. So the force is really the electric field strength times the charge. The electron has a charge, elementary charge, 1.6 by 10 to the negative 19 coulombs. And if you're sitting for ACE Physics paper 1, that's one of the pieces of data given to you on page 2 of the question paper. So you don't need to memorize that, but maybe you would have it memorized by the time you sit for the paper, right? So the electric field times the elementary charge, the charge on an electron. For students in class, that's what we were talking about with the essential question on the chalkboard today. And multiplying these two gives you 8 by 10 to the negative 15 newtons, which is why choice D is the correct answer here. This has been another work example with Dr. Schleich. We'll see you next time.